So yesterday we were factoring based off of some patterns that we saw in our polynomial. Today we're looking at factoring a quadratic trinomial that takes on the form ax squared plus bx plus c. Now when we factor this trinomial, what we're doing is we're looking for the linear factors that would multiply together to give us the original quadratic trinomial. In order to do this, we need to remember what the greatest common factor is. Greatest common factor is simply the factor, or the thing that multiplies into, two or more expressions. All right, now before we get into factoring, let's remember multiplying using the box method. Early on in the year, we multiplied two linear equations, called factors in this case, using this thing called the box method. One of the dimensions of our box was one of the linear factors, in this case x plus 8, and the other dimension of that box was the other linear factor, in this case x plus 5. We multiplied them together to get the area of each box. X times x is x squared, x times 8 is 8x, x times 5 is 5x, and 5 times 8 was 40, which is the same as if we were to just multiply these two linear factors together using distribution. X times x gives us x squared, x times 8 is 8x. Likewise, 5x and 40 would all combine to give us the x squared plus 13x plus 40. Now one thing to keep in mind here is this middle b term comes from combining these two terms that are like terms, the 8x and the 5x. Well, today we're going to use a very similar method, but instead of multiplying our polynomials, we are going to factor them. All right, let's get into some examples. First of all, let's consider this quadratic trinomial ax squared plus bx plus c when a, our leading coefficient, is equal to 1. Let's factor x squared plus 12x plus 20. Note, again here, our leading coefficient a is equal to 1. So let's set up a little box here, and we're going to use this box method. All right, in the box, remember there are four distinct parts of that box. In this first box here, we're going to put that leading term of x squared. In our last box, we're going to put 20, our constant term. Now, these other two boxes here, these middle boxes, remember, needed to combine to give me this term 12x. So what we need to do is take our leading coefficient, which in this case is 1, and our constant term, which is 20, and multiply them together, which gives us 20. And what we're doing now is we're looking for factors of 20 that will combine to give me positive 12. All right, so let's list our factors of 20. We have 1 and 20, 2 and 10, 4 and 5. All right, now keep in mind I'm looking for factors of positive 20 that have to add to give me positive 12. All right, so as I look across here, I see that this would add to give me 21. Here's my 12, and these would add to give me 9. So 2 and 10 are the two numbers that I'm going to fill in here for my other two boxes. So this becomes 2x, and this becomes 10x. And it doesn't matter which box you choose for those two factors. All right, now we're going to get our linear factors. And the way we do this is we're going to move across each row in each column, pulling out the greatest common factor. So follow me as we go here. Across this bottom row, 20 and 10x have the greatest common factor of 10. Across the top row, 2x and 1x squared have the greatest common factor of x. All right, those were the two rows that we pulled the common factors out of, the greatest common factors out of. Now we're going to pull the greatest common factors out of the columns. So moving up this first column here, the greatest common factor between 10x and 1x is x. And the greatest common factor between 20 and 2x is 2. So across our top dimension here, we have x plus 2, and along the side we have x plus 10. And these are the two linear factors that we'd multiply together to get this polynomial x squared plus 12x plus 20. Now, it's always of good practice to check our work. So here's our two linear factors. Let's redistribute. X times x gives me x squared. X times 10 gives me 10x. 2 times x is 2x. And finally, 2 times 10 is 20. So again, you can see how this 10x and 2x combine to give me my Well, my 12x, and I have x squared plus 12x plus 20. So it does check out. And my two factors are x plus 2 and x plus 10. All right, let's take a look at another example. In example B, again, we have a trinomial where our leading coefficient is equal to 1. So I'm going to set up a box here with those 4 locations. And that first box goes x squared, and my last box is my constant term, 24. I multiply the leading coefficient and the constant term together to get the number 24. And again, this is a positive 24, so I'm looking for factors of positive 24 that will combine to give me a negative 11. All right, so let's list through our factors of positive 24. We have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, the only way that I can get these guys to add up to be negative 11 is if both of these factors are negative. So here I have negative 3 and negative 8. These will combine to give me negative 11. Therefore, into each one of these boxes, I have to place a negative 3x and a negative 8x. All right, it's time to move through our rows and columns now, pulling out our greatest common factor. So moving across the bottom row, negative 8, and 24 is going to, our greatest common factor here is going to be negative 8. Moving across the top row here, I have a negative 3 and negative 3x and a 1x squared. My greatest common factor here is positive x. All right, let's move up our columns. When we move up our columns here, we have a negative 8x and a 1x squared. The greatest common factor there is x. And we have a 24 and a negative 3x. Our greatest common factor there is negative 3. All right, now how did I know that these were negatives, a negative 3 and a negative 8? Essentially, the rule goes that if a negative touches the box here, then that dimension is going to be negative. So if these two boxes here in the corners are negative, then the factor is going to be negative. All right, so we have x minus 8 and x minus 3 are our two linear factors. Let's write that out. And now let's check our work. All right, let's do one more example here. I'm going to get it set up for you, and I'm going to let you try it on your own. Here's my box. In one corner here, I have x squared. The other corner, I have negative 36. When I multiply my leading coefficient of 1 and negative 36, I'm looking for factors of negative 36 that will combine to give me negative 5. All right, so list out your factors of negative 36 here and see what you can get that combine to give you negative 5, and then factor out your greatest common factor from your rows and your columns and get your two linear factors. All right, now let's move into some a little bit more difficult examples. We're going to follow the same method, the box method for factoring. However, now our leading coefficient's not equal to 1. Well, we're still going to approach it the same way. Let's set up our box. And here's our 4 quadrants. Now remember, we're going to list that first quadrant is our first term, so this is 2x squared, and the last quadrant's our constant term. However, when it comes to finding factors, we want factors of our leading coefficient times our constant term. So that's 2 times 50, and that gives me 100. So now I'm looking for factors of 100 that will combine to give me positive 25. All right, so let's list out our factors of 100. We have 1 and 100, we have 2 and 50, we have 4 and 25, and we have 5 and 20. Again, I'm looking for factors of a positive 100 that will combine to give me positive 25. So I see that this would give me positive 101, positive 52, positive 29, and here's my positive 25. So I'm going to list 5x and 20x in my other two boxes. And again, it doesn't matter which box I put them in. All right, now it's time to factor back through. So let's choose our orange color now. We're going to go across the bottom row, factor out your greatest common factor. Well, my GCF between 20x and 50 is positive 10. And as I factor my greatest common factor out of 5x and 2x squared, that comes out to x. All right, let's move up our first column here, 2x squared and 20x. My greatest common factor is 2x, and 50 and 5x is going to be 5. So here are 2x plus 5 and x plus 10. Let's write out those linear factors, and let's check our work by re-expanding. So x times 2x gives me 2x squared. X times 5 is 5x. 10 times 2x is 20x. And 10 times that 5 gives me 50. You can see my 5x and 20x are going to combine to give me my 25x. Here's 2x squared plus 25x plus 50. It checks out and it works.